This little project I'm working on here, I was talking to my friend Drew earlier on the radio about it, and he had never heard of the Arduinos. And you can see a little red board right here. This is an Arduino clone called a Seeduino. It's all surface mount, whereas the regular Arduinos are through hole. You can see there's a little Atmel processor right in there. Mini USB, it's 5-pin mini B. There's 3 little switches over here that control, have to do with power, and whether automatically or manually will go to take the programming. FTDI USB to serial chip right there. Various I/O along here and here. There's some power right here. You can see this is actually for the 5 volts, and then the ground. And let's see on here if we can go over the top and out of the light, you can see the bottom right hand corner there are 6 analog input on there. Then there's about 14 digital pins up across the top. You can see all this is all hooked up to. And so that's pretty much what's on the Arduino. And there's some other stuff on here for some serial and I2C and other little things like that. And a little reset switch on here comes in handy. Capacitor is 5 volts, like I said, 5 and 3.3 volts. And you can get those voltages here, and there's some reset stuff over there. So and you can actually put shields on top of these guys. So that's why these are all, you can actually see from the side. They have those, and you can, little header pins will stick down on there. And everything passes up from the shield, from the device below to through the shields and stuff. Up here, I've got some Dallas Semiconductor one-wire devices. On the left are DS18S20s, and the right is DS18B20s. There's small differences between them. First I bought the Bs for another project, didn't quite work, so then I got the 18s. And then the project still didn't work, so it wasn't an issue with the devices. It was the controller adapter deal. I didn't want to work right. So, and then down here we have your typical breadboard, good old Radio Shack. And you can see there's 3, I have some of the DS18S20s on there. And over here on this end, this one, there's actually a 4.7 kilo ohm resistor on there with pull-up resistor from 5 volts coming over here. And then the rest of these, and it's all basically all parasitic power modes. And there's 5 volts running across the top up here that's coming from the Arduino right there. A little 10K pot right here that controls the off the LCD right here. It's a 16 by 2 LCD, just your generic kind of LCD, and these are all the pins that come over here for control. It's only using 4 basically for the data. Backlight over here is on there, and then this is the main power. These 2 here, and there's some grounds and some other control stuff, and you can see these are all hooked over there. Just basically takes 6 pins. That's one of the issues. It does take 6 pins in this mode for the Arduino to drive it. But there's some other ways you can drive it with just a couple of pins, but it requires more stuff that I don't have. So I'll go ahead and turn it on, and you can see if I can get the angle where you don't get the. See, there we go. Turns on. And this is just some text. I have it scroll across there. I was playing with some scrolling text and stuff. And then there's the temperature sensors. A little bit off there between why that one's a little bit higher, I don't know. But they are 3 right together. If you look at them right there, this is the one that shows up as inside, shows up outside, and inside one. Might use this for a project at work for monitoring some temperatures in a server room. But that's basically what it is, and doesn't take a lot of code to do it. This guy has a whopping 14,333 bytes or 336 bytes of memory available to be used. So hey, you got to be really really careful with your code. I'll look up here on the screen. This is the Arduino, kind of an IDE, basically all in one. It does does all the compiling. Basically, the editor compiles and sends it. You can see up in here, this is where you can actually, you kind of test it there. You can stop, new, open, save. That's sends, and you can do, you can connect to the serial. If you have a serial, you can actually look at it from the serial port. On here, just some There's using three libraries over here. One wire, Dallas temperature, which actually uses the one wire as well. Liquid crystal drives the LCD. Just defining some stuff up here where it's on pin 9. It's going to use 9 bits precision on the temperature sensor there. Let's see, then the one wire, this all just has to do with setting up the one wire up in here. And these are basically each device has a 64-bit code serial number basically, and the first portion, the first octet over here is actually the device family. The 0x10s are the DS18s or DS18S20s. If it's a 0x28, it's the 18B20s. And I forget what the old the DS1820s were. And then on here you can see this is where it's using which pins. It's telling it which are the LCD is actually hooked to. Just kind of this void setup is just kind of how it sets up some stuff. Just so you can see it's doing the printing and the scrolling deal in the beginning. And then we can go ahead and we'll scroll down here. And there's a lot of, I've commented out quite a bit of stuff just to see how small I could get this down to. So this is all commented out, but it's just more LCD printing deal. This is some serial. You can actually watch it over like a serial monitor in here, printing out the data. And I'll scroll down here again. And basically the meat of the whole operation is down here. Or actually, right in here is where it actually tells the sensors to do their thing. And then down here is just basically where it's printing out the data. So not too much to it, and you can see down here, if I can get it to focus right, it's using a whopping 6,848 bytes. Most of that's in the libraries. So that's what I've been playing with the last few days.